be doing is going through this Terralith to Terragrunt guide over here. I've already created the Git repository that you see over here. And so I'm going to start installing the dependencies that we need in order to build our silly application. Our objective today is to make a little website that looks like this, where we're going to host an application for voting on different cat images. And we're going to consistently refactor through that infrastructure as code setup in order to get a final IAC setup that is maintainable and scalable. Let's get started. So we're going to install our dependencies here. And we'll confirm that we now have a mies.toml at the root of our repository. If folks don't know, a mies.toml file is a tool version manager used by this application called Mies. It's a useful tool that we've used across different projects here at Gruntwork. We recommend it because it lets you pin all the tools that you use. And if you've done DevOps for any duration, you know it's very convenient to be able to reproduce exactly what you do on other projects. So I'm going to go ahead and create some configurations over here for the application and start copying this application code. I see that folks are using TG Switch, and it does not have the latest Terragrunt versions. I know Mies does. I'm not sure why TG Switch doesn't. So all I'm doing here is just going through file by file, copying the contents from the guide, and pasting them in.
I use it for template.html. You named that one index.html.
You're my hero, Lewis. This is why we work together as a team. All right, so now we should be able to do our little check-in right here to make sure I didn't mess up anything else. This look good to everyone? Did I miss any files? No, I think we're good. All right. Now we're going to need to package up this application. This is going to be how we're going to deploy the application into AWS Lambda. So we're going to create a dist directory. It's going to contain the compiled artifacts and anything else that isn't source code. We're going to navigate into our application directory. We're going to install all of our dependencies with Node, and then we're going to package them up. There we go. For convenience, especially if you're running this, in your own laptop as you go through this, I highly recommend that you add in this convenience git ignore. All this does is say ignore everything in this directory except for the git ignore. You don't want to commit these zip files and these cat images to your repository. Now, I've already downloaded a bunch of cat files, so I can rsync them from my downloads directory into dist static. If you don't have any cat photos, this is a great time to go ahead and generate them. If you want to just follow along without having to generate them, you can create some empty files named o1.cat, .png, and it'll work just the same. Let's see, that was a mistake, and then I need to add an A there. So I've copied over these files, and now just to confirm, I'm going to go ahead and take a look at my dist directory. So I've got this packaged zip file and all the static assets that we're going to be using for this website. So far I haven't done any IAC or anything in AWS. So you'll note here that I'm authenticated to AWS using a profile. I'm going to do this just to refresh my credentials. Good. If you want to follow along on your device, you'll need to be authenticated to AWS, however you do that. I use a tool called Granted. We like it. It makes things fairly secure and that they're temporary credentials that are role-based. You don't need to worry about having any hard-coded credentials on your disk. So I'm going to go ahead and create a live directory, which is a best practice here at Gruntwork. We like to organize things by your catalog and your live infrastructure. You can think of the live infrastructure as the stuff that's actually out there, and the catalog as the reusable patterns that you use in your live infrastructure. So I'm going to keep going through. Same process where I just blindly copy and paste the content from the guide directly into my project. And I'll go over the actual contents of these files once I have them all in here. Let's see. All right. And now we get to the point where I need to stop blindly copying and make a decision. This file here, let's start at the beginning, is going to be used for the variables in this project. Now, this name needs to be unique across everybody everywhere doing this demo. So I'll need to be careful with it. I need to make sure that it doesn't conflict with anything you all are doing. So I'm going to try to beat you all to this name. I'm going to pick the current date, and I'm going to go 1311. The reason that needs to be unique is that S3 buckets in AWS need to be globally unique. Otherwise, you'll get a conflict with somebody else. So similar, I'm just going to keep going ahead, copying stuff. And again, we'll want to have our backend configuration stored. Now, again, we need to be careful as we've got this reference to an S3 bucket name, and that needs to be globally unique. We'll call it TF state. I'm seeing a question: why not use boilerplate for this? It's a good question. We tried to keep these guides like as low overhead as required as possible. I don't want to assume that everyone is comfortable using boilerplate or using boilerplate templates. So I'm trying to keep things generally agnostic to whatever you have installed. Now, unfortunately, OpenTofu Terraform don't have the ability to automatically create S3 buckets for users. We do have to explicitly create this S3 bucket, unlike you get with Terragrunt, where it'll just automatically create your bucket for you. And similarly, we'll need to put versioning on that, which is just a best practice. And again, it's something you get for free in Terragrunt, but because we're building things out step by step, we'll just be doing that explicitly with the AWS CLI. I'm going to start this, keep going with this project. We're going to do a layout check-in where I'm going to confirm I've got all the files I expect to exist in this project. outputs, providers, S3, vars optional, vars required, and versions. All right. Now we can go into the live directory, tofu init, and tofu apply. Now I'll say yes. And hopefully, unless somebody conflicts with me on this bucket name, this should go forward pretty smoothly. So we've got our infrastructure provisioned, and I can go ahead and run tofu. Let's do set URL, tofu output run, and then we'll do function URL. And then we can go, oh, that's an even better one. So this will open up that new website that we just provisioned over here, where we can vote on the best cat. And what's fun about this is an interactive little demo here. You can all take a look at the website as well. But as you can see on the website right now, we've got none of these images uploaded. So we've got to do a little bit of post IAC work in order to get this stateful application up and running appropriately. Don't know when that was open. Okay, so what do we need to do? We're in the live directory, so we can just run these commands and we should get the bucket name, go back to the root of the repository, navigate into that static directory that had all of our cat images, and then upload them into the bucket. So let's take a look at that. I think this is a bashism problem. So let me go ahead and do these one by one. You should be able to do this fine if you're not running fish like I am. I like to make things hard for myself. Another little bashism. And all of the cat images have been uploaded, and we can successfully load our cat voting website, which is very exciting. Feel free to vote on different cats, and they should be persisted in a database that we have provisioned. Now, I did promise to explain what we actually did with this IAC. So I'm going to go back up through it and explain it file by file. Let me know if you have any questions. I believe in a stage-based thing, you won't be able to just unmute yourself and ask a question. So please do whatever Discord requires. You might need to raise your hand and have somebody on the Gruntwork side let you speak. You might need to just post your question in the chat. So first things first, we have to define our provider configuration. So OpenTofu Terraform have these things called providers, and they're basically little plugins that are written in Go that OpenTofu Terraform know to talk to in order to do stuff that's interesting based on your HCL configuration. In this case, we're using the AWS provider. So we configure it with a given region, and based on the contents of our .tf files, OpenTofu is going to do things in AWS. We've also got this versions file, which is just a best practice for OpenTofu Terraform, where we can define any required versions for both OpenTofu Terraform and any providers that we want to use. We also define some resources that we want to provision. So this is a DynamoDB table, the details of which aren't super interesting, but they preserve the votes of our cat votes. We have the static assets bucket, which stores the actual static assets that we've uploaded, the cat images. We've got this data block, which just conveniently fetches some data from AWS. we've got this IAM file with an IAM role that our Lambda function assumes, the permissions it has to get and list objects from S3, the ability to manage DynamoDB information for our votes, and all these other attachments of these policies to the role. What might be the final file is this Lambda file where we define our Lambda function, including the source code that we're going to upload to Lambda, all these attachments of the role, configurations regarding the architecture, etc., environment variables for connecting to those the data sources, and this depends on block to make sure that we provision things on the right order. Finally, we've got this Lambda function URL, which is why it's so convenient for me to hand out a URL to access the Lambda function. In addition, we've got these variables, which just allow us to configure the Lambda function when we provision it. This .auto.tfvars file has a special name to it. When that's present in a directory that's running OpenTofu, OpenTofu will use those values for the appropriate variables. Finally, we've got our outputs, which just expose the relevant data for the resources that we provisioned as new outputs. And we've got our backend configuration, which stores our state in a remote location so that we can collaborate with our teammates even if they don't have the state file locally. And there's also some concurrency protection where two folks attempting to plan or apply the same file won't be able to do so, as one will acquire the lock and will need to release it before the other one can do any updates. Okay, so our first step in refactoring the infrastructure that we've provisioned so far is to go ahead and create a catalog of reusable configurations. We promote this as a best practice as it makes it easy to make your infrastructure reproducible because you have all your best practices codified in your catalog and it's easy to just reference that in your live IAC. So I'm going to go ahead and create a catalog /module /S3 and Lambda and IAM and DynamoDB. I'm going to move the content that was in the live directory into those reusable modules. And then I'm going to do slight modification to them in order to make them work as reusable modules. And again, this is going to be a lot of me just copying and pasting stuff from the website. So feel free to shout out any questions in the chat. I am main.tf. So the change that we've made to this file is largely just to use those variables that we've now defined instead of hard coding them in everywhere. And we're going to change our lambda vars optional.tf. Again, we're using those variables that we just defined. All right. Now we also want to make sure that we move our versions.tf file that we mentioned as a best practice into these catalog configurations. So we're going to go to each one of these modules and we're just going to copy over the live version file into them so that they all track their versions correctly. Yes, Haxor. Terragrunt is able to create these state backend resources automatically and avoid doing it manually. We just decided to do it one step at a time so that you can see what the process looks like to evolve your IAC. So Now we're just going to place this here. So now I'm just referencing those reused modules from the catalog. Now I can go to the output and you can see it used to be that we just referenced the resource names directly. Now we're referencing the module address for each one of these. We've also encapsulated a lot of the API information for these different resources. So the modules expose the variables that they care about, and we only need to set these very particular optional variables at the top level for our live infrastructure. And I believe that should be good. Let's give it a shot and see what happens. We've got a force destroy that is not expected here on main TF. That's interesting. I bet I made a mistake in my edit of the... I did. So I made a mistake when editing my S3 file here, in that the force destroy variable is not exposed. So let's figure out where I made that mistake. I can go to the S3 portion up above and see that there was a vars optional here for force destroy that I did not include. And I bet that it was a vars required that should be here. My mistake. Let's go ahead and try it again. Great success, but oh, how scary is that? If I was to go ahead and apply this IAC update after all this refactoring, we would completely destroy and recreate all of our configurations, which is pretty scary. You can run into this when you start your like IAC refactoring journey, and knowing how to overcome that is pretty important if you want to be able to make your IAC scalable. So that's the majority of what we're going to be showing you in this workshop. Please share any questions if you have them. It's a pretty important part of the workshop here. What we're going to do in order to be able to address this problem, because as you can see, we've got this static assets path that's going to be created at module.s3.abs-s3bucket.static-assets being created, and a AWS S3 bucket.static-assets that's going to be destroyed, is tell OpenTofu, hey, this thing over here is exactly the same as this thing. You can just move the resource from that previous address to the new address. So I'm going to copy this move.tf file. Do a check-in of the project layout before I continue going. See that we've got our catalog configurations. Oh geez, with the application, it does make it hard to read this. So I'm just gonna ignore the dist and application. That didn't work perfectly, but we've got our catalog, modules, DDB, IAM, Lambda, and S3, like we see here. And we've got our live configurations over here. So let's go ahead and run tofu apply. We'll get another confirmation before we hit yes. Oh, we gotta do it in here. And we'll see that we now have 0 to add, 0 to change, and 0 to destroy. So we're theoretically not going to lose any of that vital cat voting information. If folks have already, voted on their favorite cat, all of that stateful information is preserved. You could read more about the trade-offs here, but I want to just take a second and highlight them. So, in the first iteration of this project, things were pretty straightforward and pretty simple. You just put the content you wanted in .tf files in your live directory, you ran plan and apply there. And we did a lot of work to refactor that into multiple modules and to call those modules inside of the live directory. And we didn't do anything to the infrastructure that's actually running. It's the same cat app. It's got the same voting mechanism and everything. So why did we do that? There are some pros and some cons to that. So one, we got to promote reusability in all of that shared code. If we had colleagues that wanted to spin up, a Lambda function or an S3 bucket or whatever, they could reuse those common modules to get consistently reproducible results. And we were able to better document how those different resources worked. Because that module had all of the logic and the API worked out for how to create an S3 bucket appropriately, what inputs it expects and what outputs you expect to get out of it, you can better reason about what you're changing when you change certain inputs for that S3 bucket, for example. We'll see more of this as we get to the next step. We add in a new dev environment. All right. So before we add that new dev environment, we're just going to do one little quick detour where we're going to add in a higher level module that encapsulates all of those constituent resources, the S3 bucket, the DynamoDB table, the IAM, etc. Basically the contents of main.tf over here, so that it's easy to stamp it out multiple times. So let's go and do that work. And friendly reminder, if you have any questions, feel free to shout them out. It feels like we've got an issue here, and that it doesn't like that I'm trying to create a directory at the same time that I'm writing the file. Now we can add our outputs, our optional variables for the whole higher level service module. And we can go ahead and edit our live main.tf to just have the abstract module placed there. So let's try it out and see what happened. We have to tofu init. Should make sure to update the docs to highlight that. And it seems like we also need to just get rid of our outputs file, which I should also update to include. All right. Again, we get that same scary 11 to add and 11 to destroy. So we're going to have to engage in some state manipulation to tell Tofu, hey, don't worry about the fact that everything has a new address. Now it's module.prod.module.s3 instead of module.s3.aws bucket. You just need to know where they live now. So we're going to do that work. As you can see, we now have 0 to add, 0 to change, and 0 to destroy. So I'll go ahead and apply that. Now that we've conveniently placed all of our resources inside of this one best cat module, it's pretty simple to add on a new dev environment. So let's do that. And let's add back an outputs.tf file now that we have our new addresses updated. Oh, and we can do a little check-in before I go ahead and apply it. So let's do a check-in of the live directory, which has this content, just like we expect over here. And we can do the same in our catalog, which has all the content we expect over there, including this new best cat. So I'll init again. I already did init, which was important because we needed to initialize that dev module that I just added, and then tofu apply. And again, we've got 11 to add now that we're adding that dev, and nothing to change or destroy in prod. Now, I want to call out that this dev environment that we spun up is very, oh, Mac OS, don't do it to me, is very fresh. So if we load this up, it doesn't have any of the CAD images that we have in prod, and it doesn't have any of the voting information. I call this out at the end of the guide, but there are ways to automate that process with Terragrunt. You can use hooks to do things after doing IAC updates to just automatically take care of uploading those assets, but that's not the purpose of this guide, so we're not going to be going over that. And again, it's worth calling out the pros and cons here. So at a high level, we've finally reached the stage where we're at a Terralith. We've got two different environments in the same state file, dev and prod, and they're both provisioning some resources, some of which are like potentially difficult to reproduce. So they've got stateful static assets in the S3 bucket. They've got a database that needs to be preserved, and accidentally messing with any of that could cause problems for our users. Thankfully, we all use Terragrunt here, and it provides some tooling to help us overcome those challenges. So in the next step, we'll start to introduce Terragrunt and break apart that Terralith. All right. Actually, I think we do one more step before we introduce Terragrunt. So let's do that. We're gonna go into that live directory, and we're gonna move everything that's not prod into the prod directory. And we're gonna copy over everything from the prod directory into a new dev directory, and we're gonna give them different state configurations. So if we go to dev backend.tf, you can add a dev prefix to that state file. And if we go to prod, we add a prod prefix to that. We'll also need to edit our main TF files. Given that we're no longer provisioning both environments in one root module. And we're going to do the same thing here. Now, note this is the exact same content between the two files, between dev and prod. I'm switching back between them. Can't really tell. And we'll be discussing why that's important later. Yeah. So we could go through doing a plan, but I think you all expect that because we've changed the name of all this content, we're going to need to do more state manipulation. So we'll go ahead and do that state manipulation. Because we've gone from dev.module.whatever to main.module.whatever. And similarly, we'll be doing the same thing in prod. We'll also need to change what we call our outputs in each of these. And we'll need to make sure that our auto.tf-vars are updated appropriately in both. So this doesn't need any modification. Or rather the dev one does. And we want to add this little dev prefix over here, or a suffix, and we'll keep prod exactly the same. You just take a look at it before we move on. It's going to stay exactly the same. All right. So now we're going to go into this dev directory, and we're going to run this tofu init migrate state. And what that says is, hey, OpenTofu, I know that you used to think that your state location was the root of this S3 bucket, and that I moved it to a dev directory. That was on purpose. Copy over the state from the root to the dev directory. We'll do the same thing in prod. All right, so we have the state copied in both locations. Now, in addition to having all the state addresses updated, we're going to need to go to the dev root module and have OpenTofu forget about all the prod content, or we're going to need to have the prod root module forget about all the dev content. And to do that conveniently, we can use this relatively new removed block from OpenTofu. It's very convenient. So let's take a look at this. And you can see that we now have two root modules, one for dev and one for prod. This has a lot of advantages. And I guess before I get into that, let's go ahead and plan. See that there was a mistake in the auto TF-vars. I need to add one little extra path here. Call that out in the docs, but I didn't read that. Run plan again. And you can see that we're going to change one thing, which is a no op change, and we're going to forget 11 things. Let's go ahead and finish applying this before I start to wax poetic about what exactly we're doing here. And if you're curious, the one change that is taking place here is simply telling OpenTofu that the path to the source code for the Lambda function has moved up a directory, which isn't really relevant to what's provisioned in AWS. Okay. So there are some advantages and disadvantages to what we're doing here. On the plus side, we've successfully broken apart the Terralith, so we don't have one state file that's managing both dev and prod. But we've introduced a little bit of operational burden. If I want to update the dev environment, I have to explicitly navigate into the dev directory, run tofu init, tofu plan, tofu apply, do the same thing in prod. And we still have a lot of state that's commingled. I still have my stateful resources like my S3 bucket for static assets, my DynamoDB table, provisioned in the same state file that my Lambda function is provisioned, which is stateless and easy to reproduce. In the next section, we'll start adding in Terragrunt, which makes all of this a lot easier to manage, makes it so you can operate across multiple state files pretty simply, and makes it easy to refactor further. All right. And again, if you have any questions as I go through this, please do reach out in the chat. So in each of these, I'm going to create a new terragrunt.hcl file. And that's actually all you need to do to start adopting Terragrunt. So now I've gained the superpower of being able to run plans across multiple units without needing to navigate into each one individually. And I don't have to run tofu init first or anything. Terragrunt handles all of that automatically. We can use more Terragrunt features, however, in order to further expand that capability. So we can go into the dev directory and specifically run Terragrunt plan here to only manage the dev environment. And we can explicitly pass this queue_include_dir flag, which tells Terragrunt to only run the content of the dev directory. Furthermore, if you'll recall, we were saying that this content isn't really that interesting. We're just repeating the same thing across all the environments that want to produce that same infrastructure. We can actually get rid of that now that we're using Terragrunt. And this is pretty fun. You see all this content over here? We don't need the vast majority of it anymore. We can also handle setup of variables. So we don't need to have the .auto tf_vars or this vars file. We can have Terragrunt set variables itself. So let's do that. Now we will need to make sure that we set the name to the same thing it was before. And note that we also get certain convenience functions like get repo root, which lets us get the path to the root of the repository, the Git repository in HCL, which is pretty convenient. And we'll want to get rid of that dev at the end over there. Okay. Now that we've introduced our inputs, we no longer need these .auto tf_vars. And we can also get rid of the need for this here backend.tf. Because we can simply define our remote state configuration. And again, I want to make sure I use the value that I picked at the beginning of this call. And do that again in the prod unit. Now, we can also, if you'll see over here, get rid of this providers.tf file because Terragrunt provides the ability to generate any configuration file that we want on demand for our units. So I can go ahead and add that configuration to both of these. And again, in prod, we'll add that in. Now, what most Terragrunt users do instead of explicitly defining these configurations in every file is they'll refactor out a root.hcl. This is how we advise folks do it in the docs. And use a special path relative to include for the state key right there. And that will allow us to dry up our configurations and include this shared piece of content um, in every file. So now you can think of it like Terragrunt copying and pasting that stuff from include directly in here and resolving that path relative to include to the relative path from the root.hcl to each of these units. All right. Finally, as you probably expect, I can show this, I believe. If I was to go ahead and apply here, it would be bad because OpenTofu would think that we are going to destroy and recreate all of our infrastructure, which is not great. So we're going to need to do a little bit of state manipulation to avoid that. And we also no longer need this removed.tf file. So we can do a quick check-in, see that things have gotten a lot nicer. Things are very clean. And we can do a run all plan. We see that there is now 0 to change. Again, remember that we're just getting a directory adjustment in where it expects to find that zip file. And then we can run our run all apply across the entire run queue. So, again, we think this is a lot better than what we were dealing with before. You no longer have to track so many files in your live directory, and the majority of what you're tracking is in reusable components in your catalog, but there are trade-offs. We are 5 minutes until the end of the workshop, so I'm going to keep going instead of expounding on these. If you have any questions, please add them in the chat. I'm going to try to resolve this here in the next 5 minutes. And I don't think we'll be able to refactor into Terragrunt stacks, which is very exciting. But you're welcome to do that part on your own. So what we're going to create now is a directory for each one of these units, S3, Lambda, IAM, and DDB, where we're going to continue to break down the Terralith instead of storing S3, DynamoDB, Lambda into one state file. We're going to break it apart for each environment, having its own DynamoDB, its own IAM state file, its own Lambda state file. And that process isn't going to be super exciting. We just go to dev ddb terragrunt.hcl, copy this in, make sure we use the same name that we were using before. And then go to prod. Now, actually, I think I can run a bit longer after this. So I'll be able to hang around and continue finishing the workshop to show the full transition to a Terragrunt stacks, terragrunt.stack.hcl configuration. If you can't hang around, I'm sorry. Hopefully we'll be able to get you recording to see the end of this. So we've updated DDB. we're now updating dev S3. We're making sure to use the same name across it. This is prod S3. This is dev S3. That should be good. I am prod. That's good. Now we'll just need to go to prod IM. Go to lambda. Make sure that we get the right name in here. Okay, now we can check in and see that we've got a Terragrunt HCL file in each one of these units. And we will remember that we're about to remove this file and this file in each of these environments. So what's the state migration going to look like for this? Well, what we need to do is we need to get all that state that we had in that one unit that had all the configuration for the entire environment, pull it into a temporary location, and then push it into each of these units that only have the state of the constituent parts. So let's go ahead and do that. So we're going to go into dev, pull and push all the state. And again, we can head to prod and run that same process. Now we can go to our live directory and remove that content that we mentioned is going to be removed very soon. If we do our run all plan, should see some interesting things. First, note that we've got some synchronization happening here. Terragrunt's able to determine based off of these dependency blocks shown up here that some units need to run after other units in order for them to run correctly. So we're getting our DynamoDB and S3 units provisioned first, followed by our IAM, followed by our Lambda, as the Lambda function needs the IAM rule before it can get provisioned. Now, this is very hard to parse. Who knows what's happening here? I can show you pretty quickly that there are quite a lot of destroys that are going to happen, which isn't great. So again, we just need to do our state manipulation in order to tell OpenTofu, hey, don't worry about it. We just call things something different now. There we go. So after all that work, where we're just telling OpenTofu, hey, in the DDB unit, we've got this stuff moved, this stuff removed. In each one of our units, we can go ahead and do a Terragrunt run all plan. And again, have something that's a little bit hard to see. We want to make sure that all of them have something, relatively benign like that. We can simply run no color RG plan. Just take a look at that and see that we've successfully avoided destroying or creating anything in all of these units. So let's go ahead and do a run all apply. Now we could just do a run all apply from the root of this live directory, but we now have a lot more control. So we can go into the dev environment and do a run all apply there first. Confirm that we want all this stuff updated. And then do the same in prod. And if we wanted to, we could have even gone more granular. We could have gone to each individual unit. If you're doing this to a database, it's probably a good idea to go more granular, to just be extra sure that you're not going to accidentally destroy anything that's hard to recreate. All right. So there's a lot more to say about the trade-offs of this stage in the process, but I do want to give folks that have stuck around until now a look at what it looks like to refactor one more time into Terragrunt stacks. It's like one step after that. So let me go ahead and keep the train moving. So what we're going to do now is take all this content in live and represent it using terragrunt.stack.hcl files, which dramatically cuts down the amount of content that you need to track in live while keeping all of your state isolated from each other. So I'm going to create a new directory and catalog that's not modules, but units. I'm going to put all of these unit configurations in there, and I'm going to copy over this DDB Terragrunt HCL and the lock file from there in there, and for all the other units as well. So I can go into each one of these and swap out this for values.name. And it's basically going to be the same thing for each one of these. So we've made all these dynamic using this new values keyword that only is typically only used in a Terragrunt stacks context. And then we can update our dev environments, live dev, to have one of these. Now we are going to want to be careful to get the appropriate name for what we're doing here. All right. Take note that we are using this special configuration here, no.terragrunt.stack. It'll be clear why we're using that here. It makes the initial refactor into a Terragrunt stacks world a lot easier when you're transitioning from a traditional unit configuration where you just have all your Terragrunt HCL files out in a directory. So we can go to this dev, git ignore, make sure that we ignore everything that isn't the .terragrunt stack file or the terragrunt.stack.hcl file or the .getignore file. And then we can have a lot of fun and just toss everything that isn't the DDB, isn't the terragrunt.stack.hcl file. As a reminder, it's all this stuff. Get rid of all of that to only have the terragrunt.stack.hcl file, and then run terragrunt, run all plan, and have our AWS credentials expire, and then go again. Now, as you can see, there are no changes. So we're working with the exact same unit configurations with the same state files that we were before. We just have less content that we have to track in our live directory. And that's kind of the magic of the terragrunt.stack.hcl file. So similarly, we can take this file, go over to the prod directory. We already set that up. Great. So we can just do the same thing here. Add a get ignore to make sure that we don't track this content here either. Get rid of all the content. Then regenerate it using a stack. And I should have called out, Haxor was asking about this earlier regarding Terragrunt's ability to auto-generate backend configurations for users. That's what we're doing here, this root.hcl. That's what allows Terragrunt to create your S3 bucket and DynamoDB table or whatever else for you on demand before OpenTofu runs. So we're now able to delete this content. And this is all we need to track in our Git repositories. Now, again, there are trade-offs. Users have to learn a new syntax. They have to learn how this terragrunt.stack.hcl file works. There's the advantage of having a very simplified live directory. We kind of went back to when we had everything in one state file, but we got to get the best of both worlds in a sense, and that we're minimizing code duplication and preserving isolation of resources. And we get more configurations reusable in our catalog. Now, the final step before I let everyone go is the removal of this here no.terragrunt stack. It's a good first step when you're getting into stacks, but you don't need to keep it around if you know how to manipulate state. So this part here you can do on your own. It's just showing you exactly what it looks like in S3 to have your state broken up like this, and showing how we need to move state in order to get rid of that no.terragrunt stack equals true attribute. So to make sure that we are ready to do this, I'm going to run terragrunt stack generate and generate all the stacks that we have here. And then I'm going to get rid of the dev terragrunt.stack.hcl, all of these references here. We also need to do that in prod. Now that we've removed that, I can run terragrunt stack generate again, and you'll see that we have two copies of our stack. We've got one instance of our stack with no.terragrunt stack just directly next to the terragrunt.stack.hcl file, and we've got one that's nested inside of this .terragrunt-stack directory, which is the canonical way of making it so that you can ignore this content in your live directory in Git and focus on the terragrunt.stack.hcl, which can generate it on demand. And now we just run this script here, which will navigate into each unit directory, pull state like we did before, navigate to the equivalent .terragrunt stack directory, push state into there, back and forth until we're done. And we are almost at the end here. I just want to highlight that, again, you can go through this whole guide here, the Terragrunt website. and that included in the guide is a link to our fixtures where you can see what it looks like at every step of the way. Um, so you can see what it looks like during that first stage where we were doing everything with .tf files in the live directory, how as we refactor to use modules, as we refactor to use units, as we refactor to use Terragrunt stacks. And finally, we can show that if we get rid of the git ignore, in addition to, let's see, this, in addition to these .get ignores, we can run a Terragrunt run all plan, and we'll be running all of our IAC inside of these .terragrunt stack directories, which you can ignore in Git, and you can rerun everything with no changes in IAC. So hopefully that gave everybody here confidence that you can refactor your IAC very efficiently. You can choose where to make these trade-offs and how to keep your IAC scalable. As always, if you need help, we're here in the Discord. And if you need help at an enterprise level, or you need help like working through your like larger scale problems with IAC, you can reach out to us at Gruntwork, and we're happy to help you out. So, as always, I'm going to be in Discord, but that's going to end the workshop there. Thank you, everyone, for attending. I hope it was insightful for folks, and that you got a lot out of it.